Hi students, earlier I have provided the tutorial problems in third unit. I hope and thank you that you have completed that task, and let us move on to the next chapter, that is characteristics of induction motors. In this unit we will learn about these topics. So here first one is torque equation, starting torque, maximum torque. So these are all first topic related to the derivation point of view. So we have to derive these equations, and we have to relate the relation between torque equation, that is full load torque, this is called full load torque, and this full load torque versus and maximum torque, starting torque and maximum torque is related. That is the first topic. The next topic is characteristics. We have two types of characteristics: torque slip characteristics and load characteristics. So these characteristics are obtained from the relation of torque equation between torque and slip. Next topic is equivalent circuit of induction motor and phasor diagram. These two are similar to transformer, equivalent circuit, and phasor diagram also similar to transformer. Now we have to go for crawling and cogging phenomena. So already we have discussed harmonics concept in three-phase transformers. Now here also induction motor is unable to run with without noise. So sometimes it is running with jerking and over noise. So because of harmonics. So how the harmonics affecting the induction motor operation under running condition is known as crawling. If the same harmonics are affecting at starting condition, that is called crawling. So here we have two instances for induction motor, starting and running. If the harmonics are affected under running condition, the phenomena is crawling. If the harmonics affected at the time of starting, that is called cogging. So it is very important. Crawling is related to which instant? Running condition. Cogging is related to which instant? Starting condition. Next, coming to the testing. So every machine we have to test whether it is working properly or not. So for that we are having two tests. One is called no load test. It is equivalent to open circuit test of a transformer, and black rotor test. It is equivalent to short circuit test. So we have two tests, no load and black rotor. So now with the help of these tests we are able to draw the circle diagram. So it is similar to the locus diagrams of our electrical circuits. So with this circle diagram we can estimate the performance with predetermination. Predetermination means without applying actual load, if we are able to find the efficiency, that is called predetermination. Now let us move on to our first topic, torque equation, starting torque, maximum torque. So generally how we can define the torque? So what is meant by torque? Torque is defined as turning or twisting moment or force of a body tends to cause rotate around an axis is defined as torque. This is very important. For any machine the torque definition is same, but based on the principle of machine we have different torque expressions. So already we have completed the torque equation in DC machine. So where the torque expression is given by, we have relation of torque and power, that is power P equal to 2 pi 20, 60. So here P is the mechanical power and 2 pi n by 60 is the angular speed, and this is the torque. So here from this, how we can define the torque? Torque equal to 60 by 2 pi n or P mechanical. So from third unit we have P mechanical power is equal to I2R square into R2 1 minus S by S, and NR is ns, sorry, here ns into 1 minus S. So change this is NR equal to ns into 1 minus S. Okay. This is ns, and here I will replace our mechanical power and NR with ns into 1 minus S here, and I2R square into R2 into 1 minus S by S. If you take the numerator 1 minus S, denominator 1 minus S is common, so both are gets cancelled. Now the remaining term is 60 by 2 pi ns into I2R square into R2 by S. So this is our, so what is this? From unit 3 we have derived last expression, that is rotor input is equal to I2R square into R2 by S. So we can define our torque is equal to 60 by 2 pi ns into rotor input. So define here, if we use the NR as the speed, what is the power? Mechanical. If we use the ns here, what is the input? Rotor input. So this is a difference. If we use the NR, mechanical power is taken as numerator. If we use the ns, what is that power? Rotor input power in the expression 1. Now coming to continuation. So we have, this is our expression, equation 1. So from this equation 1, rotor input is given by this one. We know that in this I2R expression, that is given by I2R is equal to S into E to 0 by square root of R2 square plus S into X to 0 whole square. If you substitute here in this expression, if you substitute in the above expression 1, we will have the torque equation. 60 by 2 pi ns is common, and so this is I2R. Here we have the I2R square, so S square into E to 0 square by R2 square plus, so root will be cancelled for square root, R2 square plus Sx to 0 whole square into R2 by S. Now if we simplify this, 30 into 6, so here 3, why we are using the 3 means because it is a 3-phase machine. So this is our single phase torque, but we have the 3-phase machine, that's why we have the 3 here. We have the 3 here, so 3 into 60 by 2 pi ns S into E to 0 square by R2 square plus Sx to 0 whole square into R2. So this is our torque equation, which is also known as full load torque expression. Okay, clear? So this is our torque expression. Now coming to second one, starting torque. So here we know that at the time of starting, what is the speed of the rotor? NR is, for starting means NR is 0. So if NR is 0, what is the NS? S value? NS minus NR is 0 divided by NS. So NS gets cancelled. What is the slip at the time of starting? 1. So here In the previous expression, if you substitute the S is equal to 1, and we will get the starting torque. So here I will use the 3 again. So at the time of starting, NR is 0 and S equal to 1. To get the starting torque, substitute S is equal to 1 in the torque equation. So here we have 1S, so that is replaced with 1, and here also S is replaced with 1. So the remaining expression, here I am using 3. It is very very important. All the expressions is multiplied with 3 because of it is our 3-phase starting torque. Okay, so 3 into 60 means it is 180. 180 by 2 pi ns into e20 square by r2 square plus x20 square into r2. So in the starting torque expression, so the S is replaced with 1. So we don't have any S here. Next, coming to the maximum torque. So if we want to find any maximum value, first we have to derive a condition for maximum value, and we have to substitute the condition in the torque, that expression, to get the maximum value. Similarly here also, to find the maximum torque, first here what we are doing is derive the torque equation with respect to variable. So that will give the condition for maximum torque. So in this we have to derive our torque equation with respect to slip, because slip is variable due to change in speed. So dt by ds is 0. Here, so this is our constant term. First term is in the torque expression 3 into 60 by 2 pi ns is the constant, and here the remaining term s into e20 square, s into e20 square r2 square plus sx20 whole square to r2. So here we are deriving with respect to s, that s is present in the numerator and denominator. So it is similar to u by v formula. So this is u and v, this is constant. So I will I will remove the constant. So for that, so we know u by v formula. Dou of u by v is equal to v du minus u dv by v square. So apply this formula to this expression. Here this is our v. This is our v du, derivative of u minus u derivative of v, that is equal to 0. So if you simplify here, e20 square into r2, e20 square into r2 is the common, so both are cancelled, and remaining term, so s is present here, so remaining term is r2 square plus sx20 whole square. Here we have the 2 into, here one s is there, s, so 2 into s square into x20 whole square. Now here we have the sx20 whole square minus 2s square x20 whole square, so that will be one term. So you will get like this, and finally the condition for torque equation is this. So that is R2 is equal to S into X20. So what is the condition? Rotor resistance is equal to S times of standstill reactance, rotor reactance. So this is the very very important condition. So what is the condition for maximum torque? R2 is equal to S into X20. Now here coming to, now we have to substitute this expression in this torque equation to get the maximum condition. Now this is our maximum torque. So to get the maximum torque, substitute. What we have to substitute? R2 is equal to, R2 is replaced with S times of x20. So where we have the R2, the numerator we have the R2 and denominator we have the R2. So wherever the R2 is there, that is replaced with S into x20. Now with this we will simplify this, and finally we will get the torque expression is, that is maximum torque expression is, because of 3-phase torque 3 into 60 by 2 pi ns. If you observe, for the 3 torques, full load torque, starting torque and maximum torque, this term is common, 3 into 60 by 2 pi ns or 180 by 2 pi ns, or sometimes it is also referred as k. K is the constant, and remaining term here is E20 square by 2 times of x20. So starting torque and full load torque, in the torque expression we have the rotor resistance, but in maximum torque there is no R2, so the maximum torque does not depends on R2. It is very important question. So this is the maximum torque. Now coming to the relation between starting torque and maximum torque. So we have to use that expression, starting torque and maximum torque. Here this is our starting torque expression. So where S is not present, that is S is equal to 1, this is our maximum torque. Here I am using the K. What is meant by K? K equal to 2 pi ns by 60. K is 180 by 2 pi ns. K is 180 by 2 pi ns. 180 means 3 into 60. That's why, because of 3-phase torque. Now here we have to relate them. So for that what I am using, this is expression 1, expression 2. We divide 1 with 2. So if you divide by 1 with 2, that is starting torque by maximum torque. So take starting torque expression divided by maximum torque. Here common terms, K common, E20 square common. So the rest of the things are in common. So I will simplify this. So you will get 2 into R2 x20 by R2 square plus x20 whole square. Now I will, in order to simplify further, I am dividing with x20 square and numerator and denominator. So if we divide with x20 square, remaining term is 2 times of R2 by x20, because x20 gets cancelled, and the denominator, so we have the x20 by x20 gets cancelled, that will be replaced with 1, and here what we have, R2 by x20 whole square. Due to this, so here we know that the S maximum, condition for maximum torque, S maximum is equal to R2 by Sx2, that is obtained. Condition for maximum torque, that is R2 equal to S into x20. Now S maximum is replaced with, can I write R2 by x20? So that is taken as R2 by x20. So from this we will substitute the 2 into here S maximum, and the denominator also replaced with S maximum. So like that we can define the relation between these two. So finally the relation between starting torque and maximum torque is given by 2 times of S maximum by S maximum square plus 1.